Today we are going to learn about the bistable operation of 555 timer. Now this is the circuit diagram of 555 timer. Suppose VCC we have given 12. Now because of this potential divider, this is going to be 8 volt and this is going to be 4 volt. Now terminal 6 is grounded and terminal 2, this is your terminal 2, is provided with VCC. This is your switch. Once you press it will be go to ground. So initially it is going to VCC. Now if you want to learn the operation from here, now it is ground, this is 0 volt, this is 8 volt. Inverting terminal voltage is more, that's why it will go to minus Vset, means here you are going to get 0. Here also it is plus VCC. Now inverting terminal voltage is more than non-inverting, then you are going to get minus. How? Here 4 minus 12 into 10 to the power 5, it is going to be minus 8 into 10 to the power 5, it is nothing but minus Vset, means you are going to get 0. When S and R is 0, 0, it will remain in previous state. Suppose previous state is 0, it will remain in 0 state only. Now when you want to make some changes in this state, what you need to do, you just need to press S1. This is your switch S1. If you press S1, this terminal 2 is going to get grounded. When it will be grounded, this 12 volt, you have to press switch for a small period of time. Just press and release it. Now 12 is going to get 0. When it is 0, then now non-inverting terminal has become more than the inverting, so it is going to set at 1. Now when S is 1, R is 1, R is 0, then what output is going to get? 1 and Q bar will be 0 and your output is going to be 1 and it will remain in one state. Why? Because once you press and release it, now this 0 is again going to become 12 volt. When it will become 12 volt, then inverting terminal voltage is more than non-inverting, then this 1 is going to become to 0 because this is going to go minus Vset. When the S and R is 0, 0, then it is going to be in same state as previous state. What was previous state? It is the 1. It will remain in one position. Now if you want to make it to 0 state or low state, what you need to do, as we have learned in digital electronics, this is 4. If you give clear, if you give 0 input to clear, then it is going to clear your output, means you are going to get output 0. If I press S2, if I press switch S2, then there will be current, terminal 4 is going to get connected to ground. When it is going to get connected to ground, means clear got 0, means it will clear the output. You are going to get the output 0, means here you will get the output 0. Now this is your 555 timer. This is how connection is done. This is the small version of this one. This R1 and R2, this is just for the switch S1 and now this is just for the switch S1 and S2. This is your S1 and this is for S2, and see terminal 6 is ground, terminal 1 is ground, terminal 8 will provide with VCC, R1 and R2 just to protect switch from this direct VCC. Now in the lab the problem is that we don't have these switches. Now how we are going to do? Then what we are going to do, we are just going to take this one. Once we are connected to VCC, mean it is in this state, and for a small period of time you are going to go to ground, and again to this will be manual, means I will be taking wire and putting to ground and I will be again putting to VCC. What you will see, the output will rise to 1. And if you want to make it 0, what I am going to do, again here also I am going to do manual switching. What will be the manual? I am going to take this wire and I am going to, initially it will be VCC only, and for a small, it will be connected to VCC only, and for a small period of time I will be connected to ground. When I will be connected to ground, the output will be, it will clear the output and output will come to 0 state. This is how we are going to perform in the lab. So we are going to look at the circuit connection. Now if you look, this is a circuit that we are going to study. Now if you look, this resistance and your LED has just been connected to, so the output this has been connected to terminal 3. Now this terminal 1 has been grounded and this terminal 8 has given to VCC and terminal 6 has been also given to grounded. Now we want to learn the connection. We are going to do connection. Now connection is simple. What we are going to do, we are just going to provide terminal 2 to VCC and your this green one is your VCC, and we are going to provide terminal 4 to VCC because initially it is connected to VCC. Now this is your VCC. Now what we are going to do, if you want to learn the operation, then what we are going to do, we are going to just switch on the power supply. Now this is in 0 state, no output is showing. Now if suppose I want to make it to 1, then for some time I want to give it to 0, means I am making it 0, and as soon as I am given 0 and made to VCC, because this is switch, I am doing it manually. Once 0, and again it will go on, light will switch on for a long period of time. If you don't want to switch it off, it will not be switched off. Now if you want to switch it off, what you need to do, you need to give ground to terminal 4. This is the terminal 4 connection. I am making it ground for a smaller period of time. Again I will bring back to VCC because this is switch. Ground, output went to 0. I am going to smaller, means again VCC. Now output is 0. It will not change. And again if you want to make it to 1, now make it to 1 and make it to VCC. It will remain in 1. And if you want to make it ground, make it, if you want to make it 0, ground. And this is how switch operation is doing. Manually I am doing switch operation. Now if you want to see in both DSO, then we are going to make it happen. Now if you want to see the output, then for a small period of time I am connected to ground. See the output went to 1. Again I am connected to VCC. See output went to from 0 to 1. And if you want to make it to 1 ground, then I am connecting to ground. And see, this is your output. No output. Again if you want to make the output 1, just go to ground, and small period of time again I am given to VCC. This is manual switching. Again if you want to make it 0, make it 0 and just bring back to VCC. This is the output that we got. This is how this much amount of time it is remains in 1. Now suppose if you want to switch on again, now what we are going to do, make it to ground now, and it will remain in ground. It will switch on for a longer period. If you don't want to turn it off, leave it. It will remain in 1 only. We will see it will remain in 1 only for, we are just going to continue till this point. It will remain in 1 only. See, unless until you don't change, you don't disturb this circuit, this is not going to. That is why it is called bistable. In every state it is stable. In high state also it is stable. Now if you don't do anything, it will be remain. Now if you want to change it to ground, I have made the 4 to ground. See, it came to ground. Now this is your operation of bistable operation using 555 timer.